Okay, now let's switch to, I wanted to mention this concept of how do we figure out optimum intensity of production? What should our stocking rate be for our farm, for our animal class, for our system? If you look at, this is the so-called Mott curve. Jerry Mott was one of our preeminent American forage livestock agronomists, University of Florida, for many, many years. He studied these patterns from dozens and dozens of data sets around the world. So this works for warm season, for cool season, for annuals, for perennials. This is an extremely diverse set of data, but he found common patterns. When he graphed grazing pressure or stocking density on this bottom axis from low, so that's a low stocking rate, few animals per acre, to high, he graphed average daily gain on the left. So we're going to be at some sort of genetic potential up here. These numbers are measured kilograms per day. It's the same as 2.2 pounds. So let's say we have potential for an animal to gain 2.2 to 3 pounds per day on that left axis at low stocking rates. As we add animals, what happens to the individual animal performance? Adding animals to a pasture, it's going to start to be competition for the forage. It's going to be less forage per animal, smaller bites. What happens to the individual animal performance as we go from half an animal per acre to 3 animals per acre? What's going to happen to individual animal performance? It's going to trail off. Okay? And some people say, well, it's just a linear drop. Now, also, as you add those animals to an acre, even though each increment is performing a little bit less, a little bit less, a little bit less, we're going to build gain per acre. So that's what this right-hand column or axis, and again, kilograms per hectare, that's essentially the same as pounds per acre. So you can see as we add animals, we're going to build gain per acre to some sort of peak, and then it drops off, because beyond that, just carrying more and more animals that are closer and closer to maintenance, so there's no net gain per acre. The point of the graph is, if you want to maximize individual animal performance, it happens at a lower stocking rate than maximizing gain per acre. Does that make sense? So you have to make some choices. What is it we typically, as producers, identify with as the best choice? What do most of us think intuitively we ought to be maximizing to make money? What do most of us, what do most of us, just, top of our heads, what's our answer?
Animal performance.
Okay, well that's an unusual one. That's good. I like that. Most times when I ask this question, people say, oh, I want to maximize gain per animal because I get paid for pounds. I want to maximize that. That's going to make me the most money. Okay. What we find, what Jerry Mott tried to get us tuned into, is maximum economic return is typically somewhere in between these 2 points. It's not associated with maximizing gain per acre. And it's interesting to hear the gentleman here wants to maximize gain per animal. Ask any
That's the one that's easiest to measure.
Okay. And a dairy audience would give me the same answer. They would say, well, I want maximum milk per cow because I have a daily maintenance cost for every one of those cows. I don't want to carry more cows than I have to. Okay. So let's look at an example. Ed Rayburn, my counterpart, did some work with steers here. Let's just look at the middle line, the blue line. So as we're adding steers, 700-pound steers, where the average is 700 pounds in the season, head per acre, we're going from 1/2 to 2.5. Yes, we can see gain per animal per day drops from 2 1/4 down to about 3/4 pound. Okay. Now, what happens to gain per acre, pounds per acre, as we add those 1/2 a head per acre up to 2 1/4 head per acre? Middle line, we go up to 300, maybe 350 pounds per acre as we add animals. We maximize at this did, he modeled the economics, and it was based on a lot of assumptions, but Ed's findings were very consistent with the Mach curve. You have to back off something like 15 to 30% from this maximum gain per acre to maximize return on investment. So maximum return on investment, which also minimizes risk, as you're caring for your animals, occurs at a more moderate stock. Does that make sense?
Got a question.
Yes.
Was those cattle put on an acre left prior?
For the season. Season long.
What if they would have strip grazed that acre?
This was probably rotation of grazed.
Okay.
Yeah, I think in that case it would have been rotation of grazed.
Okay. I didn't know whether it was
Yeah,
that.
this was not continuous grazing. Yeah, but the patterns would be the same for continuous. The lines might be higher or lower, but the concept that maximizing economic returns happens at a more moderate or lighter stocking rate than maximizing gain per acre still holds. Okay, I need to move more quickly. You have this example in your handout. It's a cow-calf example showing the value of calves per acre per year. And if you study the table, what you see is you maximize calf gain per acre at, this is cow-calf pairs now, at something like 40, which one was it? I need to get up closer where I can see. You maximize calf gain per acre at 40, maximum revenue is at 45 cow-calf pairs per 90 acres. So maximum revenue, 45 cow-calf pairs, but maximum return is at, it's going to be 35 cow-calf pairs per acre. So you can study that in more detail.